Okay. I think sir have already give a brief about the different parameters with applications and their applications. So in this we will talk about specifically about some parameters which actually make more sense for Indian traffic condition. Uh, so first thing, when we talk about traffic, when we compare the traffic of different countries, we basically talk about Indian traffic is heterogeneous in nature, right? So if we see Indian traffic, we say that it's a multi-class traffic with heterogeneous and non-lane based, right? So if we think about these two scenario, the first one we see for basically most of the developed countries where we can see lane based traffics are there, right? So what is homogeneous here is that most of the traffic constitute of cars, basically identical vehicles. So doesn't mean that have other type of vehicles. It is there. Trucks are also exist in the traffic. But if you see the composition, say 90%, more than 90 or 95% of the vehicle will be cars. And if you see the nature of the trucks also, the trucks are able to maintain decent amount of speed. They are able to maneuver in 80 or 100 kilometer, right? So the second one, if you see, is usually see for typically for Indian urban condition, where we have, if we consider both motorized and non-motorized traffic, we have around 7 to 8 different classes of vehicle exist. So, and along with that, the capability of vehicles are different. Some vehicles can travel in maybe 100 kilometer per hour. At the same time, we have three-wheelers and other vehicles which move in 40 or 50. Nowadays, electric e-rickshaws are also there, which actually sharing the both same space, right? So speeds are different along with different maneuverability. You know, we have two-wheelers which can basically seep and whatever the available spaces are there, it can passes through those spaces. And the vehicles are not maintaining any lane discipline here. So whatever the space available, that try to be occupied by the vehicle. Okay. So if we are able to modeling the traffic for this condition, we need to have this aspect in our mind. Okay. So as discussed in our previous previous lecture, so basically the parameters we measure are speed, flow and density. So out of these three parameters, if we see, flow and density, speed are direct measurements. We can easily measure it from the field. However, the density is usually measured from the fundamental relationship, that is Q equal to KV. So density usually express it with the number of vehicles that is existing per in developed countries where lane discipline is maintained is vehicles per kilometer per lane. Okay. But if we are considering for Indian condition, we are not maintaining here the number of lanes, right? Lane discipline is not there. In that condition, what we can do? We can measure it in terms of number of vehicles that exist per kilometer per direction. Okay. So if you are measuring in terms of, rather than considering it the density per lane, we are considering it for the direction wise. For a direction, we are calculating the number of vehicle that is exist, and we express it how many number of vehicles exist per kilometer. But although it solve one issue, that it is considering the lane discipline, but there are some other issues are also there, right? That it is not considering the dimensions of different vehicles. Here in India, if you see, we have very small two-wheelers are also there. Along with that, we have large vehicles like trucks also share the same space. So although we are not by considering the directional directional measures, we are resolving the issue that it is considering the non-discipline nature. We are not actually accounting the different size of vehicles. Along with other aspect is different vehicles can maintain different speed. We cannot expect that three-wheelers will go by same manner as a car or a truck can go. So, the speed difference among different classes of vehicle and along with the size, that is not considered in this manner. So, to resolve this, there is a need of understanding this traffic density or concentration by with some other manners. Okay. So, for that one concept is the occupancy. Okay. So, occupancy is, if we are going by definition, occupancy is actually the proportion of time during which a single portion of roadway space is covered by the vehicles. Okay. So, if you look into the equation here, if you say occupancy along the line, that means in the cross section of road, it is measured as the summation of Ti, that is the time for which all vehicles occupy that particular line, divided by the capital D, that is the observation period. So, that observation period might be for 5 minutes, that might be for 15 minutes, depending upon our study, we can estimate it as the observation period. Then small t is the accumulation of, let us say we have observed 10 vehicles, then the 10 vehicles occupied that particular segment for a certain time period, right. So, that time period can be observed as the summation of small t. Now, with area occupancy, out of this, so we have two issues, one was with the speed and one with the size. So, speed is definitely taken care of by this occupancy, because if the vehicles are slower in nature, it will occupy for more time, right. If it is a faster vehicle, then it will occupy that particular space for a lesser duration. So, by that mean, occupancy is actually considering the speed of the nature. However, along with the speed in Indian context, vehicle sizes are also different, right. So, a slower vehicle with larger size, if it is moving, and a small vehicle with slower speed it is moving, that is not accounting in this occupancy, right. So, for that, if we look into this occupancy also, occupancy is also having a relation with the density parameter. So, occupancy is proportional to the average length of vehicle and the density. Okay. Now, if we measure occupancy in our real life, right, in practice we cannot, it is difficult to measure the occupancy for a particular line, rather than we will measure it for a small segment. Okay. So, here what is the thing, we are rather than measuring it on a line, we are considering, let us say, a small segment of 5 meter, 10 meter we can consider, and along that line what we can do, we can consider it as a detection zone, and in that detection zone, same thing, we are measuring it for a duration of time t. So, that this capital time t might be for a 5 minute or 10 minute duration, and in that duration we will see this, the vehicles, how much time these vehicles will take to navigate this 5 minute or 5 meter or 10 meter detection zone. Okay. So, that time will come as the summation of small Ti. So, now from there one thing is known, that this occupancy now, if you are saying it measuring for a small detection zone, then it depend on the length of the detection also. If the detection length is small, occupancy value will be different, and if it is, let us say, for a longer detection zone, the value will be different. So, for the same road segment also, the occupancy value might be different depending upon the length of the detection zone. Now, for heterogeneous condition, while we are measuring occupancy, what we can see, as I mentioned, we have around 7 different types of vehicle exist. You can see two-wheeler, motorized two-wheelers are there, motorized three-wheelers, cars, bicycles, light commercial vehicles, that are the small pickup vans, and buses and trucks, all exist here in the same roadway space, right? So these vehicles have different static and dynamic characteristics. That is, their maneuverability is different. They can maintain different speed, and so all these aspects need to be considered while estimating the occupancy. Okay. So to analyze such characteristics, it is necessary to consider the width of the road, as we mentioned. Along with that, the length and width of the, that is area of the vehicle, also should be incorporated. So if we, along with the travel time, if we consider the area of the vehicle also in the calculation, then in that way what will happen? All vehicles dynamic characteristics, size, also the vehicle size, also the vehicle speed, both will be incorporated in the estimation, right? So for that, a slightly modified version of occupancy is proposed, that is called the area occupancy. So what area occupancy do is, area occupancy along with the time of the vehicle, travel time of the vehicle, the area of the horizontal projected area of the vehicle is also considered in the estimation. So for a given stretch of road, area occupancy is expressed as the proportion of time the set of observed vehicle occupy the detection zone for a chosen set of roadway. So if you are looking into the definition, so earlier definition, if you see the occupancy, it was the summation of Ti by capital T, right? That is the total observed time, and small Ti is the, if for the detection time, that is occupied by the vehicle. Now if we are introducing here capital A, that is the area of the detection zone, length and width, along with the area of individual vehicles, that is been added in the occupancy, then it becomes area occupancy. Now this area occupancy, what it is do, along with the speed, it is also characterizing the size of the vehicle. So small ai is the area of the vehicles are considering. So if larger vehicles are there, that means occupancy will go up, occupancy value will go up. So along with the speed, the area is also considered in the calculation. Yes. So speed will be factored with this small Ti, that is the time that is spent in the particular detection zone. Let us say the detection zone is for 5 meter or 10 meter, whatever one detection in the detection zone. If the vehicles are moving faster, it will be there for lesser time, right? So speed is accompanied by that, and area is also accompanied here. Now, so what are the advantages of using this concept? So area occupancy is not affected by the length of the detection zone. We will go, if you see, because it is considering the area, it does not depend on, earlier the problem is, if the length of the detection zone is different, the occupancy value will be different. So that will be taken care of by this method. The other is the effect of heterogeneity and this land discipline is also incorporated here. As discussed, we are considering for the entire width of the road. So it is an indicator of roadway traffic concentration for any flow level, because its ability to accurately replicate the extent of uses of the road. So if it is uses by different classes of vehicle, how different classes are using it, that is also been incorporated here. Now we will go a little bit about how it is measured in the field, and For that, there are two cases are there. So, let us say in measuring the area occupancy, we are saying that the detection area is not been the concern. So, we are considering here two cases. So, first case is when the detection area is less than the width of the vehicle. So, if you can see in the case 1, here detection width, if you see, it is lesser than the width of the vehicle, and case 2 is when the detection area is bigger than the detection width is longer than the length of the vehicle. Okay. So, now if we are looking into the measurements here, three times you can see basically the time we discuss here, TIAO. This time can be actually divided into three components. Okay. So, the first component here is the time taken for the projected area of the vehicle to fully cover the detection zone. So, let us say in the first case here, the vehicle just reached the detection zone, then time T1 will be the time till this vehicle will cover the detection zone. Okay. So, here width of the detection is less than the vehicle width. So, vehicle is partially actually covering the zone. Similarly, for the case 2 also you can see that here also during this T time, once the vehicle reached the beginning of the detection zone, it fully entered into the detection zone. That is the T1 time component we can consider. So, the time T2 is the time period which is after time T1, during which the horizontal projected area of the falling vehicle on the detection zone remain unchanged. So, this is basically the time till from the beginning to end. Once it is fully covered the detection zone till the vehicle's rear end reaches to the beginning of detection zone. So, you can see that the area remains same in this time period. Similarly, here T2 is the time when once the vehicle is fully covered, it is moved towards the end of the detection zone. Then time 3 is the time taken by the vehicle after T2 to clear off from the detection zone. So, these three time components can be observed. Now, while measuring this the area occupancy here, we can see one thing, that in both cases the distance travelled by the is equal to L plus D, right. During this time, the actual distance travelled by the vehicle is length of the vehicle plus the length of the detection zone, right. So, once the vehicle entered, then it covered the length of the detection zone, and then once it exited from this one, it also covered the length of the vehicle itself. So, in both cases, the distance of the detection zone plus the length of the vehicle is covered during this T1, T2 and T3 time. Now, while doing the measurement for this area occupancy, there are certain overestimations are there. Okay. So, what is the overestimation happening here is that if you are going to look into this definition of area occupancy, what is happening here? This AI is the area of the vehicle. So, here, so this is the time space diagram of one vehicle that is plotted. Okay. So, in this time space of vehicle, the line here is the front end of the front bumper of the vehicle, and this one is the rear bumper of the vehicle. So, here we are not considering two vehicles, just one vehicle to show how overestimation is happening here. So, this is the front bumper, this is the rear bumper of the vehicle. The vehicle passes through that particular segment. What is happening if you look into the equation of area occupancy, there the area that is been mentioned, that is been the constant, right? The area should be the constant. Here if you see, the area is being constant only for during this T2 time, right? T2 time is the area, that is the time where area remain unchanged. So for the first for the first case, area will be the width of the vehicle plus the length of the detection zone, right? Because the detection zone is lesser than the length of the vehicle. In second case, the unchanged area will be width of the vehicle into the length of the vehicle, because detection zone is longer than the vehicle. But if you look closely in this T1 and T3 condition, that is when the vehicle is entered in the detection zone, and while vehicle is, and the T3 when the vehicle is exiting. So there you can see the area of the vehicle will not be the, it will change dynamically, right? It will start from 0 like here, then it will enter, right? So if we consider this entire area, then this pink shadow you can see, these are the overestimation that will happen, okay? So to minimize this overestimation in both cases, what can be done is, either we can consider this T1 plus T2, or we can consider T2 plus T3. Similarly, in similar fashion we can do for both cases, so that in a way what will happen, the actual occupancy here is this this shaded area you can see, that is combination of A plus B plus C. If you are considering it is the entire area, that is T1, T2, T3, then it will include this overestimated D and E area, okay. Similarly, in the second case, the desired area is this A, B and C, but along with that, if you are considering the entire T1, T2, T3 component, will include this D and E area also, okay. So to reduce this overestimation, what we can do, we can consider this T1 and T2. If we let go of this portion, we can see that this C and D are of similar area. So if we consider, so by this what will happen, we can see that A, B, C is equal to A, B, D or B, C, E. So by considering these two components, the estimation will be better. So similar run can be done, similar thing can be done here in the case 2 as well. So by considering this T1 and T2 or T2 and T3, we can remove the overestimation from the area occupancy concept. Now if we see the relation, so I will not go to the derivation of this one. So if you see the relationship between the density and area occupancy that is derived, you can see that density and area occupancy is proportionally related, and you can see this relationship actually is observed same for both case 1 and case 2, when detection zone is lesser than the width, the length of the vehicle, and when the detection zone is more than the width of the vehicle. So one good thing with area occupancy is it is not changing because of the detection length. So that's how we can see. So from this we can infer that area occupancy can be actually a viable surrogate of the density measurement, and it actually incorporate the true heterogeneous nature of the Indian traffic condition. Okay. So with that, I think I am done with this one. So sir, if you wanted to take some more minutes, you can.
Oh, what time we are having lunch? We can break
Yes, yes. Yeah, yeah. Yeah, yeah.
You can switch on mic and then ask
Yeah.
because like even online people will are able to hear if you are able to switch on mic.
One more.
Okay.
There were two different time slots. Two cases, one vehicle covers the entire.
Okay. Yeah.
Uh,
Yeah. So, yeah,
yes.
here.
Yeah. Uh, I mean, having two cases, two variability. Why don't we just make that time space big so that just we remove the case one and get into case two, make the area very
No,
big.
so the idea behind is to show these two cases are that it is incorporating it is regardless of the as we discussed in the earlier the occupancy concept, the occupancy value will be different for different detection zone. If your let's say detection is too small or too big, having in the same roadway, it will give you different occupancy value. But here in both cases actually that thing is taken care of.
Well, why do we make, for
So
example?
here why it is lesser than 1 meg. So see there might be multiple things here. So one is with the sensors. So loop detector is in one thing that is used in many. So if you measure it by loop detector, your width is mostly it will be lesser than this one. Whereas if you are measuring occupancy with say camera, then you can have a more bigger detection zone. So depending upon the nature of instrument or data collection, we can choose actually different type of detection zone, and we can set things accordingly.
Okay.
Yeah.
Excuse me, sir.
Yes. Yes.
Sir, would you like to throw some light on the thing about loop detector which you just mentioned?
Loop detector, I think Ashish sir will give better, will cover about this.
We will talk about it in the future lecture. So go in detail about that.
Yeah, loop detector and those things will be covered in detail. So maybe just like be patient. So even if it doesn't get answer like once this loop detector thing got covered, so always you can raise the same question whatever your query is.
Sure, sir. Sure, sir. Thank you.
From online participant, any other questions? Just unmute yourself or raise your hand so we can entertain your questions. So whenever you have a question, like either you write in chat box or just raise your hand, we will be able to figure it out. So if no question, then like it's currently 1:10. So we'd like to start again 2:15.